So we're going to start example 2 exactly the same way. We're looking at finding the prime factors of 400. As we go to find those, things to remember are numbers that end in 5 or a 0 can be divided by 5. Numbers that end in 1 0 can be divided by 10. And numbers that end in more than 1 0 can be divided by 100 or maybe even 1,000. So as we look at 400, we notice that it has two zeros, which does mean we can divide it by 100. And if we do that, we would get 4 and 100. So neither 4 nor 100 is a prime factor. So we're going to have to do the prime factors of each of them. 4 comes from 2 times 2. And then 100, we have some choices. We could do 2 times 50, 4 times 25, 5 times 20, 10 times 10. All of those are possibilities. We just need to pick one set. I'm going to go with the 5 times 20. 5 is a prime number, so that part of the tree is done. However, 20 isn't. So as we go to look at that, I'm going to go with 5 times 4. You could have done 2 times 10. And then 4 is 2 times 2. Okay, so there's our prime factors. Now, one of the questions I get is, does it matter which numbers I use as I go to find my prime factors? And so if we take a look at this one and do it again using 400, what we can notice is instead of doing 4 times 100, I could have done 40 times 10. 40 is 4 times 10, and 4 would be 2 times 2. 10 is 2 times 5. So that part is now a prime factor. Going back to our 10, we get 2 times 5. And as we look at that, notice that we have done different factors as we went through. But if we look at the first one, we have 1, 2, 3, 4, 4 2s and 2 5s. Here we have 1, 2, 3, 4 2s and 2 5s. So again, it doesn't matter which numbers you use as you go to find your factors. By the time you get down to the prime factors, they will be exactly the same. All right. So now that we have our prime factors, we're going to take that 400 under our radical sign, so the square root of 400, write it into our factors. So as we look at it, 1, 2, 3, 4, there are 4 2s, and there were 2 5s. Notice my radical sign is not quite long enough at this stage, so you do have to expand the radical sign so that it goes to the end of the last number that should be under it. A lazy radical sign does not work and needs to be fixed. So now, looking for our index, remember no visible index is an index of 2, so we have a 2 there. As we go to look at it, we are now going to circle numbers that are the same in groups of 2. So 1, 2, these guys go together and they can come out. These guys get to go together and come out. And we have 2 5s that get to go together and come out. Notice in this scenario, we have no leftover numbers under our radical sign. So as they come out, the first circled group becomes 1, 2. The second circled group of 2s becomes another 2. And then we have the circled groups of 5 that as it moves out becomes 1, 5. Because there is nothing left under our radical sign, we are not going to write a radical sign. Okay, so then at this stage, multiplying those numbers together, we get 2 times 2 is 4, times 5 is 20, and there is our final answer. So perfect squares can work, and so do perfect cubes. What happens if you have a perfect square is everybody will be grouped up, and you will not have anything left behind.